Hello everybody. Today I am going to solve some important numericals on Prism of class 12 physics. All the numericals are very important and they are of different kinds. So let us try to understand question number 1. A ray of light incident normally on one face of a right isosceles prism is totally reflected as shown in the figure. What must be the minimum value of refractive index of glass? Give the relevant calculation. Okay, so from here you can see in the figure the angle of incidence will be 45 degree. For total internal reflection, angle of incidence must be greater than critical angle. So I greater than IC, that is critical angle, and I is 45. So 45 greater than critical angle, or we can rearrange IC less than 45, not taking sign on both the sides, and putting the value of sine 45, we get mu greater than root 2. So this is the answer. Now in question number 2, a ray of light incident on an equilateral glass prism propagates parallel to the base line of the prism inside it. Find the angle of incidence of this ray. Given refractive index of glass is root 3. So here from the figure you can see the angle of refraction R is 30 degree. We can write refractive index of glass with respect to air, that is sin I by sin R. So refractive index of glass is root 3. So root 3 equal to sin I by sin 30, or sin I equal to root 3 sin 30, putting the value and getting the value of angle of incidence. So sin I equal to root 3 by 2, which is replaced by sin 60, because the value of sin 60 is root 3 by 2. So in this way we can calculate angle of incidence equal to 60. A ray of light passing from air through an equilateral glass prism undergoes minimum deviation when the angle of incidence is 3/4 of the angle of prism. Calculate the speed of light in the prism. Okay, so here given angle of incidence equal to 3 by 4 into A. A is the angle of prism and its value is 60. So I equal to 3 by 4 into 60, which is 45. So I equal to 45 degree. In minimum deviation we know that R equal to A by 2. Since A is angle of the prism is 60, so R equal to 60 by 2 equal to 30. Again we can write mu equal to sin I by sin R, and I is 45, R is 30. So putting the value of sin 45 and sin 30, we get mu equal to 2 by root 2, which is root 2. Now speed of light in the prism is given by V equal to C by mu equal to 3 into 10 to the power 8, and mu equal to root 2, which is already calculated. So V equal to 3 into 10 to the power 8 by root 2 equal to 2.1 into 10 to the power 8 meter per second. Question 4. A ray PQ incident on the face AB of a prism ABC as shown in the figure emerges from the face AC such that AQ equal to AR. Draw the ray diagram showing the passage of the ray through the prism. if the angle of the prism is 60 and refractive index of the material of the prism is root 3, determine the values of angle of incidence and angle of deviation. Now here is the required calculation. Here angle of the prism A equal to 60 and mu equal to root 3. So now we can use this formula I plus E equal to A plus delta. This is equation 1. Since QR is parallel to BC, hence this is the case of minimum deviation. So in case of minimum deviation, I equal to E. So 2I equal to 60 plus lambda, okay, or 2R equal to 60 or R equal to 30. Here you can see how I have written 2R. In a prism, R1 plus R2 equal to A. Okay. So in case of minimum deviation, R1 equal to R2, which is equal to R. Let us suppose that R1 equal to R2 equal to R. Then from the given formula R1 plus R2 equal to A, we can write R plus R equal to A, that is 60. So 2R equal to 60 or R equal to 30. Now mu equal to sin I by sin R. So mu is root 3. So root 3 equal to sin I by sin R, that is 30, already calculated here. So sin I equal to root 3 by 2 or I equal to 60, because root 3 by 2 is replaced by sin 60. So sin I equal to sin 60. So I equal to 60. Okay. Now from equation 1, 120 equal to 60 plus lambda or lambda equal to 60, because in equation 1 you can write I equal to E and I is 60. So equation 1 becomes 60 plus 60 equal to A, which is replaced by 60 plus lambda. In this way we can calculate lambda equal to 60. Okay. Now the next question, question number 5. Figure shows a ray of light passing through a prism. If the refracted ray QR is parallel to the base BC, show that R1 equal to R2 equal to A by 2. Number 2, angle of minimum deviation DM equal to 2I minus A. We can use the formula R1 plus R2 equal to A. Since QR is parallel to BC, so R1 equal to R2 and I equal to E. This is the case of minimum deviation. So 2R1 or 2R2 equal to A, so that R1 equal to R2 equal to A by 2. Now for the deviation DM equal to deviation at the first phase plus deviation of the second phase. Okay, the first phase, that is AV, and second phase AC. So DM equal to deviation at the first phase plus deviation at the second phase, which is replaced by I minus R1 plus E minus R2 equal to I plus E minus R1 plus R2. Since I1 equal to, I plus E minus R1 plus R2, since I equal to E, so 2I minus R1 plus R2 is replaced by A. So dm becomes dm equal to 2i minus a. In this way second part has been calculated. Angle of minimum deviation dm equal to 2i minus a. Now question number 6, the last question. A ray of light is incident on one of the faces of glass prism of angle A, has angle of incidence 2a. The refracted ray in the prism strikes the opposite face, which is silvered. The reflected ray from it, retracing its path, trace the ray diagram and find the relation between the refractive index of the material of the prism and the angle of the prism. So first of all, you go through the figure. You will find that angle of incidence I equal to 2a. Okay. Now we can write mu equal to sin I by sin r, which is sin 2a by sin r, equation number 1. Now in triangle XQR, we can write 90 minus r plus a plus 90 equal to 180. So here r equal to a. So this is equation 2. From 1 and 2 we get mu equal to sin 2a by sin a, which is equal to 2 sin a cos a by sin a equal to 2 cos a. So a equal to cos inverse mu by 2. This is the answer. So thank you for watching this video. Do not forget to like, share and subscribe.